Alright, let's get started on this problem. So, this is the first problem of the day, LeetCode number 721, accounts merge. Given a list of accounts where each element is a list of strings, where the first element is a name, the rest of the elements are emails representing emails of the account. Now you would like to merge those accounts. Two accounts definitely belong to a person if there is some common email to both accounts. Note that even if two accounts have the same name, they may belong to different people, as people could have the same name, okay? A person could have any number of accounts initially, but all of their accounts should definitely have the same name. After merging the accounts, return the accounts in the following format. The first element of each account is the name, and the rest of the elements are the emails in sorted order. The accounts themselves may be returned in any order, okay? I didn't quite get that, but let me just double check to see. Let's see what they mean. Okay, so we have accounts. So we have John with two accounts, then another John with two accounts, but no similarity between this John and this John. This Mary has their own name, and this John also doesn't share an account. First and second John are the same. Oh, do they? Oh, they do have the same. They do have an email that they share. Okay. Okay. The third John and Mary are different people, as none of their. Okay. We could return the list in any order. However, the emails inside must be in sorted order. Okay. So let's see. So the main key, I guess, is that if two lists share a common email, then the two lists should be merged, basically. Okay. So if the two lists share a common email, then the two lists should be merged. Sure. Otherwise, do not merge them. So, chances are, this is probably not an interval merge slash, well, not a merge intervals type problem. Because in this case, there really isn't any sort of overlapping intervals in the same way, at least that I feel, right? What I'm leaning towards at the moment is using some sort of hash map where we connect. Do we want a hash map? Let's say we do a hash map by name, first of all. With key value name list emails, we'll say. Emails in this situation isn't actually like a data structure or a class that we're going to be making, at least as far as I know for now. But it's just something for me to think about, just to make it a little bit more clear. So we have a list, or we have a hash map where the key is the name of the person, and we have a list of emails, right? Then we can say for each name within the hash map, if there exists more than one list of emails, so this will be actually a list of emails, then we need to check them for a merge. And, well, considering that we need to sort the emails anyways, we might as well do that now. So the idea is that we sort them now, and then we can sort of evaluate the strings in a different way. I wonder if we could perform maybe a binary search in that case. Perform a binary search for any intersection. That's what I'm thinking. Because once we sort the emails, we could probably perform a binary search. And I know that Kotlin has a native binary search function. We just need to sort of we might need to do a little bit of finagling if the string wrapper in Kotlin doesn't actually implement a comparable, but it should be. So we should be able to run a binary search on the lists after we sort them. So this would be O of E log E, where E is number of emails, right? And then this would be O of log E. It's a little bit weird considering that E is a bit of a special term in mathematics, but we'll deal with it. So log E is performing the binary search each time for each email. And since we do it for each email, E log E will probably be our time. We could also consider using a set for this. Because a set would give us, this would give us O of 1, our constant time retrieval for contains, right? So that would give us constant time contains, but we'd have to add an additional data structure on top, basically. Well, let's see. Let's assume that all emails within an account are unique, right? Then what we do is that we store each block of emails within a set rather than a list. Then no sorting. Well, we still need to sort it, but retrieval and basically checking for matches is lowered to O of E time, where E is the number of emails in any given set, right? And we can do n times E, where n is the number of accounts with the same name. Then at the end, what we do is that we would produce a new list, which is the set .to list sorted, and the name of the account holder. I think that actually makes a lot of sense here, because we're going to be doing essentially an intersection. We're going to be checking an intersection against all the lists, right? Because without this, we would be doing n times e log e, and now we're breaking it down to n times e, though we do have to. I think regardless, we're going to have to store more information. We're going to need to store additional information because even in the case of using a list, we would still have to produce a new list which only contains the emails without the name of the account holder. So it really doesn't change much about our memory usage, in my opinion. And the set just allows us to do that retrieval, do that dot contains within constant time rather than linear or even logarithmic time. We no longer have to perform binary search because we can just use a set. And in this case, because we don't really care about the sequence, we can just store it within a set. Like, we don't care about the sequence or the order of the emails initially, right? We can do the sorting later. So all we really need is to see whether or not they share an email. And in that case, we could use something like a set in order to find it faster. Though this problem kind of feels like it might be a candidate for a pattern which I am personally incredibly not familiar with. Something, I think it's called like union find or something like that. Maybe this is something that is like some place where this is applicable, and maybe I'll do a little bit of searching into it after we solve the problem in this manner. So overall, the algorithm will take it'll take e time in order to go through all the emails, where e is the number of emails in the largest set. But I guess the question really then becomes, okay, if we do find a set, if we do find a match, well, we can produce a new set, which is the union of both sets, and then remove the individuals. But would we need to would we need to start again from the beginning? Because we know that a set maintains an order based upon insertion. We know that if we have a match, then we would likely insert additional items, and that any item that exists before would have been matched already. Let me think. So if we find a match between two sets, we no longer have to care about the second set for a comparison, but we need to care about the third set and onwards. And also, let's just revise this to be a list of set of emails then. And in that case, we would be running through that n times, yeah, for the number of emails. But would we need to restart that every single time? Is it possible to start in the middle? That might be an optimization question for later. We'll just start off by just saying like, okay, we'll just start it at the beginning again. It doesn't really matter too much, right? So I think this is a decent point. Let's see, produce a new set, which is to list. This would be O of n. This would be O of n, assuming n is the number of email sets that we have. And let's see. Would it be O of n times O of e? Or O of n plus O of e? Because for each set, we need to convert it into a string. And suppose that that set takes an O of e time, and we need to run it for all of n. So then it would be O of n times e time in order to turn all of those sets into a list. Times, I guess, a, where a is the number of accounts. And let's say that we do this sorting, right? So this sorting would be here. So this sorting would be O of n times O of e log e, because we need to sort each individual one, and each individual email block would take O of e log e time to sort using quick sort. And we'd have to do that n times for each email. And then we'd have to do that for each account. And therefore, the total time for this last step would be O of n times O of e log e times O of a. So let's see. So O of n times O of e log e times O of a, and then that would be additional, in addition to our O of n times e for sort of, and actually this would be O of n times O of e times a as well, because we had to scan through the entire hash map, right? For all the accounts, we'd have to perform the same operation. Okay. I think that's reasonable. So this would be O of n e a times O of n e log e a. And then that would be dominated by the second term. So O of n times e log e times a would probably be our final runtime for this algorithm, for this total algorithm. What about space? Well, we need to store each item or each email within per account within a set. And let's not count like the output as part of our space, just our auxiliary space, right? So we'd have to store each email per account. We'd have to store each account within a hash map. So this is O of a space, right? Because we'd have to, our hash map would have to be as big as however many accounts we have. This would be O of a times n. Store each account per name, or I guess email list per account. And there could be up to n, as we said, email lists per account. So that'd be O of n, or O of a times n, and then store each email within each email list. So O of a times n times e, essentially, because we have emails per a email chain. So our total space would be O of a times n times e, I believe. So I think this is a decent amount of analysis, and I think that our solution is somewhat let's say, optimal. We can't get rid of checking through all accounts, right? Because we have to just scan through all the accounts. We know that we have to sort the emails for every account, so we can't get rid of that elog e. Do we have to check all the emails, though, within each? I think so, because we need to check all the email blocks per account or per name, because we don't really know which ones intersect with each other. So I think that this is a decently optimal solution, and I think that at this point we would just get started coding. So let's start off by creating our, we'll call it a name map of, this will be a list or a string that will denote our name, and it will be a list of set of string, and this will be a mutable set, I think. Actually, I think this can just be a straight set. Then accounts for each name. If nameMap.getName is equal to null, so if it doesn't exist within the map yet, then we can do accounts or nameMap.put. We add our name at 0, which is the account, and then name.take1.toSet as our value. So name index 0 is we're taking the first item within our name, which is a list of strings, and the first one will always be the name of the user. Name take1, I forgot if it was take or drop, except the first n elements. So we want to drop the first element because the first element is the name, and then we want to do a toSet because we want it as a set rather than a list. And this should actually be a mutable list because we want to actually get the list itself, and we want to append to that list, right? So we can say val name list is equal to nameMap.get at name0 as mutable list of set of string. And then we can add our name drop 1.toSet. So if it does exist, we grab the list, the mutable list, and then we just add to that immutable list our new name toSet. So this is sort of filling up the map with a list of all of our emails. Now we can say name map for each name. We can say val, or this should be, let's see, when we iterate through a map, does it give us both the key and the, I believe it's an entry, right? It's an entry with a dot key and a dot, let's see. It gives us a dot key and a dot value, if I recall. Yes, it gives us an entry with a key value. So we'll call this entry. And then we can say entry.val. I think it's value dot for each. So this entry, this value is the list of set. Let's see. I wonder if we need to do an n squared operation here, because we'd be checking the rest of the sets for each set. That's a good question. And also, are there any set operations that we could use that might make this a little bit easier? Could use a union. Is there an intersection? Okay. So what we could do in this case because we'd have to search through each element, right? So I wonder if I want to use a fold here. We could try using a fold. And what this fold does is that we start off with one value, and we'll start off with the initial value. And it takes in a lambda, which has an accumulator. And this accumulator will just be entry.value 0 as well. Or we can just say entry, or no, that will shadow it. We'll say accumulator, and then our operation is here. Let's see. Let me just double check that this accumulator is what we want. This would be the next set, I think. If accumulator intersect next set is not empty, accumulator equals accumulator dot union next set. But we kind of need to do this for each one, right? So entry.values.forEach. We can say email set. Email set.fold. No, but this fold operation, this will take the, hmm. Let me think. Could do index in 0 to entry.values.size -1. So this will go through each item in the set, and if entry.value at index intersect entry value index +1, so this needs to go to the last one, and this is not empty, then entry.value of index is equal to entry value index dot union entry value index +1. So if there is an intersection with the next email chain, then we union, and we set it to our current value. Or we could do this. We set it to the next value, so we fold it into the next one rather than folding it back previous. And then the purpose of that is that then we can do entry.value.remove at index, so we can remove our set from there. We can remove our set from our old set before we've merged them from our list. Let me see if this will work. So we'll print line, and also we'll do like a return a list of list, or list of list string, which is empty, just so the compiler is happy. Intersecting entry.value.index, and, or this should be unioning entry.value index +1, and this is to -2 because it's inclusive. And we can say print line entry. Let's move this up. Actually, I want to print it afterwards just to see it. And this should give us the key and the value, and hopefully it's in a way that isn't dumb. Let's run this and let's see if there's anything that we need to fix so far in terms of mutable map of. Did I miss a? It seems like I did miss a, because this one's that one, this one's that one, that one's for that one. Yep. So I looks like I missed an angle there. Let's see. Ooh, it looks like we. Okay, let's see. For each arguments list string to any. For each name, inline for each. So it looks like we can't do a for each there. So we can say for name, which is, or what do we want to call it? Name entry, which is of list string in accounts. I think that's how you do a for each. Let's just duplicate this and let's double check. For each, I want to do it just the standard for each. For loop in. Yep. Okay. Cool. Awesome. I think we can just replace the logic here because it seems like this inlining isn't working out. Oh, we need to do this name entry. And then I think that should solve it. Still a type inference failed there. Oh, whoops. That's the wrong one. And then name list is get that as mutable list of that. And then we should be able to just add this and then to set. Infer type is set string, but mutable list set string was expected. Why? This is a name list, or this is a mutable set string. We should be able to add a set into it. Maybe that type inference here, or maybe this mistake here would be able to fix it. No, it seems like this is still being an issue. So we know that this name entry drop one is a list.toSet. And this is a set. Oh, this one is not happy. We need this to be a mutable list of, and then we can just drop that in there. Sorry, it was actually erroring at the wrong at a different line than I was looking at. Let's see, if index plus 1 is less than entry.value.size, because we don't want to make a mistake there. Okay, so John ends up becoming this, this, and this. And then we print it. Looks like that's actually all right. It seems like it's working all right, actually. Let's actually run the second test case to make sure that it's... So we should be getting 3 in each. But actually there's no overlap here, so there's no reason to. Okay. Each entry again. What we'll say is that entry for each, because now we're not mutating it anymore, and we'll say email list or email set. We'll create a return list, which is a mutable list of string. We'll do a return list.add. This will add our entry.key this will add a list of, which will initialize with our entry.key. Then we want the result of our email set dot toList dot sorted. I wonder if list of allows for us to does list of allow us to maybe I could do a mutable list of actually it would be this sorted with sorted, let's see, sorted doesn't exist within interesting, there's a sorted set. There's a sorted set? What is a sorted set? Huh. There is a sorted set. In that case, can I use a sorted set? If I do that, well, is there still a union operator here? Not quite. Interesting, though. Sorted set. And this set is an interface. And I'm assuming that there is no, like, union. Tunnel clear equals hash code split. Yeah, there's no union operator and intersection operator, looks like, within the set. I mean, we could do an add all. And contains all. Or we'd have to do a contains for each element, which just sounds like additional work, so don't really want to do that. So let's just keep this as a set for now. Keep it as a Kotlin set, rather. And then what we will do is that we will say val turn or list we can say, is email list still a thing? No, we can just say list without emails. This will be a mutable list. Or actually, this could just be a list. But I don't want to add, I don't want to do a plus operator there. This is surprisingly tricky. It really doesn't need to be. Screw it, let's just do a list of entry.key, and then we'll return list without emails plus entry dot or email set dot to list dot sorted. I think it's just sort, right? Let's see, sort. I think it's just sort. And that's natural ordering, right? Should be. And then we just add it there, and then we just return list. Sort is not allowed. To mutable list. And let's see. Man, this for each is like really not liking my my usage of it, surprisingly. Type inference failed. This should be a list of set of string. I believe, right? This should be entry value, which is a list of set. Yeah. Oh no, it's for each of those. So type inference is having a field day right now. Cannot be applied to that y. List any, but list string was expected. And this key should be a string, right? We can say list string. So that should clear up the bottom one. Looks like Kotlin type inference is just not having fun here. Of type string. Infer type is list any, but list string was expected. Interesting. Plus email set dot to mutable list dot sort. Can I do that? Infer type dot to string. Is this entry key really not a string? Oh. I think it just wasn't able to type inference that one. No, it's still saying that that's where the type inference is failing. As list string. Unit cannot be sorts it in place, right? That's why. Okay, that's why. List, what do we do? Email list of emails is email set dot to mutable list of emails dot sort return list plus list of emails. This shouldn't be necessary here. Honestly, this shouldn't be necessary here either. We need a mutable list because we need to sort it, because lists are completely immutable. That's fine, but I mean, we expected that to work because there really aren't any changes there. Let's check out the other one. I know that we were doing some work there. That seems to have worked, but I'm wary of the runtime of this, because this is actually potentially O of n squared. It's potentially O of n squared, because we'd have to check the first one against all of them, right? And then we just have to slowly merge them. I mean, like, that's just how it feels like it's being done. Let me think about this a little bit more. For each entry there, so for each account, so this is checking for each account, so this is O of A. And then this is O of N. This inside here is secretly hiding an O of E. But we need to run through this multiple times, right? Because we could potentially have, we have n accounts, and let's say that they all work together, then it would be, we'd scan it, we'd scan here, then we'd remove that, remove the, let's say they have something in common, we move it up, then we scan the next one, then we move it up, so if they all have something in common, then we don't actually do a for loop for the whole thing. We just do one scan if they have something in common. So actually this is correct, I think. It's actually O of n times E log E times A, or O of n times E times A, in order to union and intersect all of them. If they have something in common, then it'll just basically accumulate over time. I think that there's a way to sort of use a fold rather than there might be a way, but the fold, I'm not sure if folds can be, if they work, if they have to be, if they're conditional, because as far as I've seen, like the folds are usually like they just fold something like completely, like there is no condition component to it that like stops them basically. As far as I've seen, I could be wrong for that though. Or Or maybe there's like a fold if. That's not the fold that I want. Fold on collections. Is there like a fold if? There's a fold index, fold right index, fold 2. But fold 2 isn't quite what we want either. Yeah. Anyways, I think that we have a decent sort of solution here. Let's see if it actually runs out of time or if some other issue comes up. Ooh, it looks like we have a wrong answer here. So our input is this. Let's check this. So we expected to just get one entry out of it, and we got 3 entries out of it. And we can clearly see that there's still a little bit of overlap. Let's see. Let's take a look at how it's coming along. Okay, so we union the first one. So we start off with 1, 2, 3, 4, 5. We union the first, probably the first one. Oh, there are duplicates. Okay, that's fine. It's fine if we have duplicates because we're using a set. Okay, so we kind of dodged a bullet there. So union the first and second one. And then we union, there's a 1, 4, and 3. That's that. Which one is that one? 1, 4, and 3. It's this one. With the 0, 1, 3. Which is this one. Let's see. Entry.value index. I want to see how this plays out. If index plus 1 is less than entry value size, we'll do that. Let's see. So we're at entry 0, 4, and 3, so that's the first one. Then we union this one. We union this one so that it's here, and then we remove that. Oh, so the index goes forward still. I see. Can I modify index? Or is index a value here? If index is a value here, we'll create a var index then. So this is standard. While index is less than entry.value.size -1, because it's less than, not less than or equal to. Then we know that this will always hold. And we know that this should always hold as well, because we should always be less than that. Let's take a look again. Okay, there you go. Yeah, so we just had to back up by 1 when we did that union. Let's make sure that we didn't regress on any of the tests. And how far did we actually get into here? Okay, only 11 out of 50. But given the speed that this ran at, I am very concerned about time limit exceeding. Oops, I forgot to remove the line on... Oop. Get another wrong answer. Wait, didn't we just run the test for this? Oh no, it's a different one. Let's see where we get. This shouldn't be, the print line entry at the end shouldn't be interesting because it's just one person. Print line entry.value index and entry value index +1. So this doesn't union with this. But realistically, it should union with this. Gah. So it doesn't union with that one, right? And that's the problem. That is a problem. That is a problem indeed. Maybe we just go for the... Maybe we just go for the dumb route first. Let's see how far that takes us. Index in 0 to entry.value.size. Actually, we could do this. We could keep the while loop. And then we can do for index in... Or... I in 0 to, basically we need a double for loop. So this would be O of n squared times e to entry dot value dot size minus 1 if entry dot value at I intersect with, actually this would be entry, we can val current entry or current email block is equal to entry dot value at index, and we can say if entry dot value at I is not our current email block, because we don't want to union with ourselves, and current email block intersect with our entry dot value at I, then not current email block, entry dot value at I is equal to current email block dot union with entry value I, and then we just remove our current email block. So we would do entry dot value dot remove at index. So this basically runs a double scan across all of them. Now I'm thinking an index to the last one. Then we remove at I. Then we want to do at index. So we aren't overriding the current email block as a value. We're overriding the reference that it's underneath. And then we just union that dot is not empty. So the idea is that we start here. We will run through the rest of the array. If we find a value, we'll union it to what we have currently, and then we'll remove that item. I'm not sure if this for loop will actually work though, because we know how for loops, they execute once. They seem to execute once with their calculation. So I'm not confident in this. I'll call this inner index. I'll start this at index. I'll say while this inner index is less than our entry value size, and then here we'll do inner index plus plus. Basically, we just want to make sure that we're not, we could do this actually, index plus 1. That way we never mess with intersecting our own. And then we can print line unioning current email block and entry value in inner index. And if all of them happen to be intersections, then we just basically just delete the whole thing, right? So there's no need for that. Let's see. The problem is that once we add an item in, we don't know if our new set, our new superset, actually contains something within some other sets, right? And that's sort of the problem that we ran into before as well. So we kind of need to do a index minus minus here if we find something, because we want to reiterate over our current index. I think that works. Let's give this a shot. Okay, cool. So we union the first one and this one. And then we unioned this the superset of this one with 2, 3, and then this one with 3, 4, and then this one with 4, 5. Let's run through our first case, our example cases. Let's run through our incorrect case for the first one. Ooh, looks like we ran into an out of bounds exception. And that was with our example 1. Let's see. Well, what we could do is that we do this instead. So we actually union it forward and we remove our current value. And the reason why we do that instead is that then we know for sure that the value is ahead of us. So we will run into it again, or at least we should. It seems like we don't. 0, 4, 3 and 5, 0. Okay. Let's see. And then 1, 4, 3. This should be 0, 4, 3, 5, but we don't see it. Let's see, print line. Current email block should be gone at that point, but entry.value inner index should not. Let me think. So 1, 4, 3. That, and then that brings us this, which just isn't right. If I move it up, is it correct? Is it removing the index that we want it to be at? 0, 4, 3, 5. That is correct. Why is... See if there's any situations where index is equal to inner index. No? Well, maybe the key to debugging this is just figuring out, is just printing the state of the entry dot value after all this. After each step. So we get 0, 4, 3. Now I'm just thinking if we should further push this. This is taking longer than I expected, but this feels like a design question, at least a more designy question, not really like a solve this problem necessarily. But it is to a certain extent. I think the problem is that actually we're kind of doubling on our stuff. And we don't want that. Let me think about this some more off camera. I'll be back. Okay, so I tossed in a couple of submissions this time. I decided to go back and take the strategy of basically once we find an intersection for our set, we union it with the other side, and then we delete the set on the left. That way we don't have to really mess around with the indexes as much. And basically that's just how I expect it to work. And it looks like it's still a little bit on the slow side. And unfortunately, this is where I guess like my patience ends, and the amount of sort of brain power I have to really continue and think about optimizing this further sort of ends for this problem. Definitely will check out some of the solutions that have been posted though, because this is definitely not optimal to just fold it once. I've basically enforced it so that I only fold it one time, rather than like folding it all the way through if all of them match, if all of them intersect. And yeah, that's just not quite as optimal. But yeah, in any case, I hope you learned something, and I'll see you for the next problem.